Whatever I've achieved, I owe entirely to the Vedantu team. It's not just the in-depth subject matters that were taught to us, but also the exam-specific strategies we were asked to use.
Hi guys, क्या हाल चाल है? Hello everybody, this is Saurav here and welcome to the chemistry session on the Vedantu channel where we are discussing electrochemistry. Hello Ajay, hello Anit, and I hope a number of other people are still on the way to join the session. So as you can see that this is the third session on Faraday's law. अभी तक हमने 2 sessions कर लिए हैं Faraday's law पे, and 2 sessions में हमने काफ़ी कुछ आइडेंटिफाई कर लिया है. We have identified okay, we have identified what is a reaction which takes place, or what are the reactions which takes place in a electrolytic cell, how does electrolysis takes place, and if how electrolysis takes place we can also identify that what are the different products, what is anode, what is cathode, and हर reaction का outcome judge करने में हमारे पास 4 factors थे, and these 4 factors were pretty much utilized as like the guiding factors to identify what will be the products. ये सारी चीज़ें हमने कवर की थी. हमने number of cases हमने लिए थे. I remember we had taken about 6 cases. I'm fine, thank you. So namaste Gaurav. Hello Nick. You're joining us from Mizoram, very nice. Hello Sujit. Hello Suraj. So we had discussed about 6 cases where electrolysis was taking place. We will take 2 more cases today, and we will talk about what was the work of Michael Faraday in electrochemistry and why we are talking about Faraday's law. Okay, so very nice to see everybody over here. So before we start, let's see how much we have completed, but before that please do like, share and subscribe the channel. Please do tell your friends to join us on the channel, subscribe, hit the bell icon so that you're always updated with the all amazing content which comes up. Okay, we have until now covered electrolytic cells, Faraday's law, and we have also done electrolysis cases. Okay, we have also done electrolysis cases. So we'll take 2 more cases and then we'll jump on to what this topic is more focused on. However, electrolysis cases the questions will be asked very directly. एकदम direct questions आएंगे. आपको दिया जाएगा कि ये reaction है, ये electrode है, बताओ इसके products क्या होंगे. So the outcome should be on your fingertips. Outcome should be on your fingertips. Okay. Okay. So somebody is asking that why sir KVPY SB category. So SB category, since it is not the session for KVPY, I'd like to tell you that KVPY SB category is for kids who are in the first year of the undergraduate course as BS Sciences, BA Sciences or BSc Sciences, BStat, BMath courses में अगर हैं, so they can appear. You are in BTech, you can't appear. So if you are in those courses in the first year, then you can appear. But I guess if you are not on the if you have not taken admission in any particular college where you are an undergraduate student, that does not apply to you. Okay, so KPY classes will be starting very soon. Shimon sir will be taking the first class. Probably the first class would be today, and the schedule is already out. Please do check the schedule, and the classes will be like, please let your friends know कि हम लोग KPY की classes कर रहे हैं. KPY की classes को बहुत अच्छे से follow कीजिए, because we will be discussing previous year's questions as well as probable questions which can come in KPY. Okay, our sprint had a lot of success and people had like almost exact questions, exact concepts getting replicated in the final paper. So please do watch the KPY sessions very diligently. Okay, so with this idea in mind, चलिए start करते हैं आज का क्लास. आज की क्लास में हम पहला केस लेंगे. There is a case which is still left out. Electrolysis of aqueous copper sulfate with using copper electrode. Okay, electrolysis of aqueous copper sulfate with copper electrode, and these are the reactions which are given. So copper sulfate, when it's being electrolyzed, we have some ions which are competing. Okay, some ions which are competing. Yes, Saroj, I can read your comment. So these reactions are competing for cathode and these reactions are competing for anode. At cathode, reduction will take place. At anode, oxidation will take place. Now you can see what are the reactions over here for cathode, and how do we judge the outcome? How do we judge the outcome? Delta G should be either negative or as less positive as possible. Delta G should be as negative or as less positive as possible. So if I look at what are the competing reactions, we have two competing reactions. Can you see these values? Can you see these values which will for the two reduction reactions that will take place at the cathode? For this 0.34, can I say for this plus 0.34, if electrode potential is positive, delta G is negative, and if this for this reaction, delta G will be negative, and for this reaction delta G will be positive. तो बताइए कौन सा reaction favorable होगा? Okay, which reaction will be favorable? Will this reaction be favorable or this reaction be favorable? कौन सा reaction favorable होगा? Which reaction will be favorable? Will copper's Cu2 plus conversion into Cu is more favorable, or H2O conversion into H2 is more favorable? Which is more favorable? The one for which delta G is negative is more favorable. हमेशा याद रखिए, delta G which is negative is more favorable. So this one is gonna happen at cathode. तो cathode पे हमें क्या मिलेगा? Copper. What we would obtain at cathode is copper. Okay, what we would obtain at cathode is copper. Let's look at what will happen at anode. Okay, let's look at what will happen at anode. Can you see these values? These are the values for the competing reaction at anode. ठीक है, दोनों reactions को देखिए. Anode पे कौन से reactions आपको दिख रहे हैं? You can see both these values are positive. If both these values if both these values are negative, E naught values are negative, so इसमें delta G इसके लिए भी positive होगा, and delta G for this will also be positive. Okay, delta G will be positive for both of them. So anode, what will be given out? Anode, what will be given out? Please tell me. A lot of people are saying, Prabhat, Anit, Ajay, which Vedansh, a lot of people are saying oxygen. A lot of people are saying oxygen, and this is where things go wrong. This is not going to happen. ठीक है? This is not going to happen. देखो क्यों नहीं होगा ये? When you are performing the electrolysis with copper electrode, so this electrode is copper, this electrode is copper, then this electrode is copper, then what will happen is that anode पे एक और reaction parallel चलता है. Okay, at anode one another reaction will run parallelly, which will be Cu changing into Cu2 plus, giving out electrons. There would be one another reaction which will run parallelly, because you are taking copper electrode. You can see that the copper electrode लिखा गया यहाँ पे. So the electrode can also undergo oxidation. Okay, now what is the oxidation potential for this? We can see that the reduction potential is plus 0.34, so oxidation potential E naught value will be minus 0.34 volts. Minus 0.34 volts, and if this is minus 0.34 volts, the least positive value will, so we have rather than two competing reactions, पहले हमको लग रहा था कि दो competing reactions हैं, नहीं, हमारे पास तीन competing reactions हैं, this and this. Okay, we have three competing reactions, और ये तीन competing reactions होने के कारण what we will do is we will take delta G for this as well, delta G इसके लिए भी positive आएगा, which is the least positive value, The least positive value is for this one. So rather than getting oxygen at anode, you will be getting copper. Okay? You will be getting copper. Is that understood? So remember that when you are performing the electrolysis of aqueous CuSO4 using copper electrode, the electrode can also undergo oxidation. Okay? Electrode can undergo reduction, the ion can also undergo reduction. Okay? So Cu2 plus can undergo reduction, fine, that's not a problem. But over here the anode can also undergo oxidation. So see, ये वाला third reaction आप miss अगर कर दिए, you will make a mistake. Clear? Remember, whenever this substance is being electrolyzed using copper electrode, we have to take copper's oxidation also into consideration. Lovely? चलो आगे बढ़ते हैं. Let's take the next one. अब इसको बताइए क्या होगा. You are performing electrolysis of aqueous AgNO3 using silver electrode. Okay, aqueous AgNO3 using silver electrode. So ये दो reaction जो हैं वो cathode पे compete कर रहे हैं. These reactions are competing for cathode. Okay, these reactions are competing for cathode and these reactions are competing for anode. Now, I have taken only one reaction. I have taken only one reaction for anode. Why I have taken only one reaction? Can anybody tell me? Why I have taken only one reaction? Because the another anion which is present is NO3 minus. Another anion which I have taken is NO3 minus. Usually anions will move to anode for undergoing oxidation. But NO3 minus will not undergo oxidation. इसका oxidation नहीं होता है. So it doesn't get oxidized. It doesn't get oxidized. इसको कैसे explain करते हैं? Because if I calculate the oxidation state of nitrogen, तो nitrogen का oxidation state है यहाँ पे +5. ठीक है? Nitrogen's oxidation state is +5. Imagine karo there is a tree. Okay, there is a tree. Fine. If I look at nitrogen, nitrogen's lowest oxidation state can be -3 and highest positive oxidation state can be +5. Okay. So tree में nitrogen का जो -3 है वो यहाँ पे present है, यहाँ पे कुछ 0 होगा and over here there is +5. Now, when you are at the top of the tree, you can only come down. You cannot go even further up. आप इसके ऊपर नहीं जा सकते हो. So you can always come down. So this is what is happening. Nitrogen's +5 oxidation is the highest positive oxidation state that it can have. It cannot undergo oxidation. Okay? Is that understood? Chalo. With that idea in mind, let's discuss what will be the product. What will be the product? उसके ऊपर गया तो भगवान के पास ही जाना पड़ेगा. बिल्कुल सही. तो पहले बताते हैं कि कैथोड पे क्या रिएक्शन होगा. चलो बताओ कैथोड पे क्या रिएक्शन होगा. Ag plus is changing into Ag. E0, what is the value given? +0.8. H2O converting into H2, it is given as -0.83. Which reaction is more favorable? For this delta G is negative and for this delta G is positive. Which reaction is more favorable? This reaction is more favorable. ठीक है? तो हमारे कैथोड पे हमें मिल जाएगा सिल्वर. Silver is getting deposited at the cathode. ठीक है? Silver is getting deposited at the cathode. Very good Prabhat, very good Anit, very good Ajay, very good untold story. What is going to happen at anode? What is going to happen at anode? Sachin Yadav, this has been discussed earlier. Please do watch the previous videos. Okay? Please do watch the previous videos that whatever is getting deposited should have a delta G negative, delta G value as less as possible. Okay, as less as possible. So ये as less as possible, इसका negative value है, इसका positive value. It will have delta G क्या बताता है? Delta G tells us the feasibility of a process. Okay, it tells us the feasibility of a process. If the process is feasible, then it is going to happen. Negative values of delta G means feasible process, positive values means non-feasible process. तो अगर negative आ गया तो it will be feasible. So this process is feasible. Now at anode what will happen? At anode what will happen? Anode में तो कोई competition दिख नहीं रहा है. Okay, anode I am not seeing any competition. So I will directly write oxygen, but if I write oxygen, what will happen? If I write oxygen, what will happen? Will it be correct or will it be incorrect? बताइए. अगर मैंने कोई competition दिख नहीं रहा है, I can say that okay भाई सिर्फ एक ही reaction है, तो I will write oxygen. Will it be correct or incorrect? Will it be correct or incorrect? बताइए. Please tell me, will it be correct to say that oxygen is getting produced? Silver electrode, you are taking silver electrode. It's not correct. Shubham Yadav, Sachin Yadav, it's not correct. You are taking silver electrode. So the moment you take silver electrode, silver also has a used as an electrode. So these electrodes are known as reactive electrodes. Okay. So what is the E naught for this? The E naught value for this is minus 0.8. The E naught value for this is minus 0.8 volt. So if I take E naught value, so this is a reaction which is competing with this one. Okay. अरे common ion यार common ion effect नहीं, it's not common ion effect. You are using silver electrode, silver will also undergo oxidation. So you must have heard of something known as electro-refining of a substance. तो आप करते क्या हो कि you take a impure electrode as anode and pure metal as impure metal as anode and pure metal as cathode. Why do you do that? Because the anode can also undergo oxidation. So वहाँ पे जो oxidize होके निकल गया, that will come into the solution and go and settle on the surface. Okay, copper की होती है. Yes, Sujal. That is why we are taking silver electrode over here. तो silver electrode अगर हम लेंगे तो silver will also undergo oxidation and will compete with this. इन दोनों के साथ compete करेगा. And if it competes with this, what will gonna happen? Minus 1.23. तो इसके लिए delta G क्या होगा? Delta G will be positive and delta G will be positive for this as well. For which case delta G is less positive? For which case delta G is less positive? Untold story, there is no copper over here. Okay, for which case delta G is less positive? Silver, so anode पे भी यही reaction होगा. Okay, anode पे भी यही reaction होगा. This reaction will take place at anode. Is that clear? So whenever you see copper sulfate with copper, do not forget to oxidize the electrode as well. Okay, whenever you see AgNO3 with Ag, do not forget to oxidize the electrodes as well. Clear? Chalo. Electrolysis of aqueous H2SO4. Okay, ये हमारा last case है. Electrolysis of aqueous H2SO4 बहुत common सा case लेते हैं ये. Aqueous H2SO4 में what is the cation? In aqueous H2SO4 what is the cation? The cation is H plus oxidation or H2O. What is the cation? H plus. So H plus can undergo reduction. H plus can undergo reduction or H2O can undergo reduction. Both mean the same thing. So cathode पे absolutely कोई competition नहीं है. We do not have any we do not have any competition at cathode. Okay, we do not have any competition at the cathode. So ये जो electrolysis करते हैं, this electrolysis is being done. This electrolysis would be done using platinum electrode, This will be done using platinum electrode. Okay, so this case is the only case for cathode, and at cathode I will get hydrogen. Since there is absolutely no competition, hydrogen will be obtained at cathode. What will happen at anode? Two reactions are competing. Sulfates oxidation is happening, water's oxidation is happening. Sulfates oxidation is minus 2.01 volts. E naught value for water's oxidation is minus 1.23 volts. Which reaction is more favorable? Very good, Prabhat. Yoga Hiran, OH minus nahi rehta hai. OH minus is not present. So this reaction will have delta G value which is positive. For this reaction, delta G is positive. Which reaction has a less positive value of delta G? This one. And so I will get oxygen. Doesn't it look like electrolysis of water? Electrolysis of aqueous H2SO4 looks like electrolysis of water. लग रहा है कि नहीं? वाटर का इलेक्ट्रोलिसिस करते तो क्या मिलता है? हाइड्रोजन एंड ऑक्सीजन. एक्वस H2SO4 का भी इलेक्ट्रोलिसिस कर रहे हो तो हम क्या मिल रहा है? हाइड्रोजन एंड ऑक्सीजन. सो इट लुक्स वेरी सिमिलर टू इलेक्ट्रोलिसिस ऑफ हाइड्रोजन वाटर. ओके, अ सिमिलर केस वाज ऑब्जर्व्ड विद Na2SO4, Li2SO4. ये भी इसमें भी देखा है हमने. ओके, Na2SO4 के इलेक्ट्रोलिसिस में भी हमने देखा है कि वहां पे प्रोडक्ट्स हाइड्रोजन एंड ऑक्सीजन ही मिलते हैं. So remember, they could give you a multi-option correct question कि they will say कि which electrolysis reaction is similar to the electrolysis of water, as in like products जो मिलेंगे वो water के electrolysis में जो products मिल रहे हैं वो. So एक case हो जाएगा aqueous H2SO4, another case could be aqueous Na2SO4 और Li2SO4, MgSO4, K2SO4. ये सारे cases में all of these cases will have hydrogen liberated at the cathode and oxygen liberated at the anode. Is that clear? But agar मान लो, if I increase the concentration of H2SO4, okay, if I increase the concentration of H2SO4, then sulfate can be oxidized if we take concentrated H2SO4. If I take concentrated H2SO4, I will get sulfates oxidation will take place. So how do we know that an electrode too will undergo oxidation in reaction? Mohammad Zunaizo, if we see a reaction where an electrode is made up of the same ion which is present in the electrolyte. For example, copper electrode in copper sulfate, silver electrode in silver nitrate. यहाँ के cases में क्या होगा कि electrode will also undergo oxidation. Is that clear? So remember that whenever, in which case, देखिए केस लिखा गया है. केस किस केस में सल्फेट का ऑक्सीडेशन होगा? जब हम सल्फेट का कंसंट्रेशन बहुत ज्यादा कर देते हैं. If I take concentrated H2SO4, I will get sulfates oxidation. Unless and until I take concentrated H2SO4, sulfate का oxidation नहीं होगा. Okay, you have to remember this. You have to practice this. Okay, प्रैक्टिस करने से उसको याद करने की जरूरत नहीं पड़ेगी. प्रैक्टिस कीजिए, कुछ क्वेश्चन सॉल्व कीजिए, इट विल बी इजी. क्लियर? चलो, लेट्स मूव अहेड टू Faraday's law. So this guy is on whom the whole topic is created. Okay, on whom the whole topic is created. Michael Faraday. Michael Faraday was a genius. He was like one of the most brilliant people ever lived on this planet. Like you can say that he is chemistry के हिसाब से अगर आप देखो तो Michael Faraday is equivalent to Nikola Tesla as physics. So Michael Faraday was a genius. Okay, so Michael Faraday was a genius because he gave these laws on electrochemistry way before electrons were discovered. Electron की discovery हुई 1896 में, and Michael Faraday came up with this idea somewhere around 1854 to 1849 के बीच में. Okay, so yeah, Faraday सेम ही है, तो Faraday कोई दिक्कत नहीं है, ठीक है. ये बुक शॉप पे काम करते थे, अब ये मुझे नहीं मालूम, आई हैव नॉट रेड द हिस्ट्री फॉर हिम, बट नेवरदलेस एक बात बताओ कि इलेक्ट्रोलिसिस में इलेक्ट्रॉन्स की इन्वॉल्वमेंट हो रही है, इलेक्ट्रॉन्स आर गिवन आउट, इलेक्ट्रॉन्स आर टेकन इन, एंड दिस गाय डज नॉट नो अबाउट इलेक्ट्रॉन्स, he knows about ions, he does not know about electrons, and since we know about electrons, our understanding becomes easier. But this guy, at the time when he gave these laws on electrolysis, or when he explained these laws on electrolysis, आपके पास electrons की discovery भी नहीं हुई है. Okay, so what is Faraday's law on electrolysis? तो Faraday law करता क्या है? Okay, Faraday's law करता क्या है? Faraday's law का सिंपल ऑब्जेक्टिव है. आप देख रहे हो कि यहां पे in all these cases of electrolysis, when I pass current, some substance is getting produced at the cathode, some substance is getting produced at the anode, isn't it? Okay, some substance is getting produced at the cathode and some substance is getting produced at the anode. If I look carefully at this process and I want to mathematically identify that if I pass a certain amount of current, how much substance will be how much substance will be liberated. So if I want to identify how much reaction is occurring, like quantitatively, I know quality wise. So दो analysis होता है, एक होता है qualitative analysis, one is known as quantitative analysis. Qualitative analysis means I know what is the amount of what is the process which is happening. Theoretical model मुझे मालूम है, using electrode potentials I know what reaction will take place. For example, electrolysis of water, I know that hydrogen will be liberated, oxygen will be liberated. I know this. Electrolysis of Na2SO4, I know hydrogen will be liberated, oxygen will be. Electrolysis of copper sulfate using copper electrode, I know copper and copper. मुझे ये मालूम है, but if I want to exactly estimate that this is the amount of substance which will be liberated at the respective electrodes for this amount of current which is passed through, then I will use Faraday's law. Okay, so it relates the amount of material produced at the electrode during an electrochemical reaction to the total charge passed, or equivalently the average current and total time. So if I want to identify कि कितना reaction हुआ, so the answer to how much reaction, okay, so I will write over here, so how much reaction becomes a quantitative result. Okay, how much reaction becomes quantitative result, and which reaction becomes a qualitative result. Okay, which reaction becomes qualitative result. ठीक है, so quantity जो अगर हम identify करते हैं उसको हम बोलते हैं क्वांटिटेटिव एनालिसिस. अगर हमने आइडेंटिफाई किया कि प्रॉपर्टी क्या है, तो हम बोलेंगे क्वालिटेटिव एनालिसिस. ठीक है, सो आप इसको एक और तरीके से समझ सकते हैं. सपोज एक मूवी रिलीज होती है फ्राइडे को, अभी लायन किंग रिलीज हुआ था. सो लायन किंग में कैरेक्टर्स कैसे हैं, मूवी कैसी है, हाउ आर द इफेक्ट्स, व्हाट इज द साउंड क्वालिटी, हाउ इज द वीएफएक्स. If you want to discuss this, this is qualitative analysis. उसकी प्रॉपर्टी बता रहे हो आप. But how much money it made, what is the cost of the seat that you sat on, how much money the popcorns wala made by putting a stall over there, that is quantitative result. Okay, so outcome दो तरीके से measure किया जा सकता है. I can measure what is happening and I can measure how much of it is happening. So how much of it is happening is quantitative and what is happening is qualitative. So our discussion until now was based, or we were focusing on qualitative. हमने सिर्फ identify किया कि क्या reaction होगा. Which products will be obtained? I have identified. But how much of them will be produced? Will be identified using Faraday's law. So Faraday's law will help us identify how much of the reaction takes place. Okay? So with this idea, let's talk about what is the first law of Faraday's first law of electrolysis. So Faraday का first law of electrolysis कहता ये है कि states that the chemical deposition due to flow of current through an electrolyte is directly proportional to the quantity of electrolysis passed through it. Okay, is proportionate to the quantity of charge or current which passed through it, quantity of electricity passed through it. इसको अच्छे समझते हैं. Try and understand this in a very, very simple manner. Okay, so let's assume that Cu changes to Cu2 plus and gives out, or let's say Cu2 plus takes up 2 electron to change to Cu. Okay, Cu2 plus takes up 2 electrons to change to Cu. Is the current DC और AC? मैंने पहले एक्सप्लेन कर दिया था, लास्ट वाले बहुत पहले एक्सप्लेन कर दिया है. फर्स्ट फैराडे लॉ का वीडियो देख लो यार, वहाँ पे एक्सप्लेन किया गया है डीसी होता है, एसी नहीं ले सकते हैं, क्योंकि एसी अगर लेंगे तो पोलैरिटी चेंज करते रहेगी इलेक्ट्रोड की एंड वी कैन नॉट परफॉर्म इलेक्ट्रोलिसिस. ओके, सो आप ये देख रहे हो कि ये रिएक्शन है, ठीक है, ये रिएक्शन है. नाउ इन दिस रिएक्शन लुक्स लाइक अ बैलेंस्ड रिएक्शन. देख लो बैलेंस्ड रिएक्शन है. 1 इन इसका प्रीफिक्स 1, इसका प्रीफिक्स 1, 2 चार्ज 2 माइनस 2 प्लस, टोटल चार्ज 0. दिस इज अ बैलेंस्ड रिएक्शन. If this is a balanced reaction, can I write this? Okay, if this is a balanced reaction, can I write this? 2 moles of electron is, or I can first start with this. 2 electrons are required for depositing 1 atom of Cu. Can I say this? Can I say this? Don't worry about n factor. Don't go to n factor, guys. इसको समझने की कोशिश करो. बहुत सिंपल चीज़ है, इसमें n factor अभी तक लेके मत आओ. Why do you want to complicate your life? जिंदगी आराम से चल रही है, उसी को ऐसे ही चलने दो. 2 electrons are required for depositing 1 atom of Cu. Or I can say that 2 electrons are required for oxidizing 1 Cu2 plus ion. I can say that. Now अगर मैंने यहाँ पे एवोगैड्रो नंबर से मल्टीप्लाई कर दिया, इफ आई मल्टीप्लाई दिस विथ एवोगैड्रो नंबर एंड आई मल्टीप्लाई दिस विथ एवोगैड्रो नंबर, कैन आई से दैट 2 moles of electron is required for 1 mole of Cu atoms. I can say this, 2 moles of electron is required for 1 mole of Cu atoms, isn't it? Now 1 mole of Cu atoms को हम क्या बोलते हैं? Atomic weight. 1 mole of atoms mean atomic weight. 1 mole of molecules means molecular weight. Okay, so 1 mole of atoms की जगह क्या हम लिख सकते हैं कि 2 moles of electron is required for 63.5 gram of Cu deposition. To deposit 63.5 grams of copper, I need 2 moles of electron. Can I say this? Very easy, very easy. ठीक है, यहां तक अभी मैंने कोई n फैक्टर का वर्ड भी नहीं यूज किया है, सो जरूरत नहीं है. इट्स नॉट मॉलिकुलर वेट दिग्विजय, ये मॉलिकुलर वेट नहीं है, दिस इज एटॉमिक वेट. एटम है ना यार, मॉलिक्यूल थोड़ी है, एटम है, ठीक है. सो उसको समझ लीजिए. 2 moles of electron is required for 63.5. now 1 electron carries how much charge? एक इलेक्ट्रॉन के ऊपर चार्ज कितना होता है? What is the charge on 1 electron? 1.6 times 10 raised to minus 19 coulomb. Okay, 1.6 into 10 raised to minus 19 coulomb is the charge on 1 electron. Clear? If I multiply this with Avogadro number, that is 6.023 times 10 raised to 23, I will get a result which will be equal to or nearly equal to 96500 coulombs. 96500 coulombs. So can you see this? 1.6 times 10 raised to minus 19 coulomb times Avogadro number gives us the total charge as 96500 coulomb. इतने coulomb को हम 1 Faraday बोलते हैं. This is known as 1 Faraday. ठीक है? 1 Faraday is known as almost equal to 96500 coulomb. I do not need the exact value, Ajay, but if you know the exact value, that is good. This is known as 1 Faraday. So 1 mole of electrons, can I say 1 mole of electrons carries a charge of 1 Faraday? 1 mole of electrons, the charge carried is 1 Faraday. Okay, is that understood? 1 mole of electrons carries a charge of 1 Faraday. फिर से बताता हूँ. 1 electron carries a charge of 1.6 times 10 raised to minus 19 coulomb. Multiply it with the Avogadro number, you will get the value as 96500 coulombs. 96500 coulombs represents 1 Faraday. So can I say 1 mole of electron carries a charge of 1 Faraday? Okay, carries a charge of 1 Faraday. So I'm erasing this part. What was the last line? Last line was 2 moles of electron is required for 63.5 grams of Cu. So can I write 2 moles of electrons के ऊपर charge कितना होगा? 2 moles of electron means 2 Faraday charge will deposit how much? 63.5 gram of Cu. Why even Earth not carry 1 Faraday charge? Why even Earth? यार मुझे आपके क्वेश्चन समझ में नहीं आया है. Okay, is that understood? So I have used this relation. What I have done, how much charge is flowing through the solution, and I have related it to the amount of substance which is deposited. This is what Faraday's laws does. Okay, this is what Faraday's laws does, and to put it in a mathematical form, I can say that the weight of substance which is deposited, is proportional to the charge which is flowing. Okay, can I see this? Will deposit weight of substance which is deposited is proportional to the charge which is flowing. Can I say this? देख लीजिए, weight deposited is proportional to the charge. Okay, weight deposited proportional to the charge. I can remove this and write the equation like this. Okay, so it will become Z is known as electrochemical equivalent. It is known as electrochemical equivalent. And how would we calculate electrochemical equivalent? It's very easy. एक बात बताओ, how much copper was deposited using 2 Faraday of charge? 2 Faraday was depositing 63.5 grams. So 1 Faraday will deposit 63.5 by 2. This will be your electrochemical equivalent. Okay, this will be your electrochemical equivalent. Electrochemical equivalent is the amount of substance deposited when 1 Faraday charge flows. Okay, 1 Faraday charge flows. So when 1 Faraday charge flows, the mass which is deposited is E. आप इसको Z भी बोल सकते हो, बहुत जगह E लिख के रखा रहता है, बहुत जगह Z लिख के रहता है. So makes no difference, this Z is electrochemical equivalent. Now how can I further write this? Q can be written as I times T. What is charge equal to? Current times time, I times T. और मुझे निकालना है कि how many Faradays, so I will divide it by 96500. So this is our equation. Okay, this is our equation. So this is very simple. ये equation मुझे use करने की हमेशा ज़रूरत नहीं है. I can just look at the question, relate the number of electrons to the amount of substance which is deposited and solve the question right over there. Okay, I can solve the question right over there. So this is a very simple relation. W equals to Z times IT by 96500. I am dividing it by प्रखर. इसके बाद का जो सेशन होगा मीन्स वेंसडे सेशन विल बी ऑन एडवांस्ड प्रॉब्लम्स. ठीक है, सो अभी बहुत बेसिक्स, पहले बेसिक तो कवर कर लें. सो दिस इज व्हाट हैपेंस. नाउ फैराडे ने दो लॉज दिए हैं. द फर्स्ट लॉ वाज दैट, द सेकंड लॉ इज दिस. द सेकंड लॉ ऑफ इलेक्ट्रोलिसिस सेज दैट इफ आई पास द सेम, अरे शिवादास, why are we dividing it by 965? Because current times I times T, current times time will give me charge. To identify charge को Faraday में convert करने के लिए, so let's say you get 10,000 coulombs of charge. 10,000 coulombs of charge will be equal to how many Faradays? उसको 96500 से divide कर देंगे. Okay? Is that understood? So relation between Faraday and electrochemical equivalent, 1 Faraday will electrochemical equivalent is the amount of substance which is deposited by passing 1 Faraday of charge. Okay, by passing 1 Faraday of charge. So second law is a extension. Second law is an extension. Second law बहुत simple है. Suppose there are two solutions. Suppose there are two solutions. Okay, suppose there are two solutions and we are passing the same amount of charge. Then let's say there are two solutions and there are two solutions through which we are passing the same amount of charge. So can I say if Q and Q is equal, this will get cancelled out and WY-Z1 is equal to W2 upon Z2. So it means if the amount of charge which is flowing is same, the amount of reaction which will happen will also be in the same ratio. Okay, सीरीज और पैरेलल लोचा नहीं समझ में आता यार. सीरीज में ही तो सेम करंट फ्लो करेगा ना, पैरेलल में तो सेम करंट फ्लो नहीं करता. इफ आई एम नॉट रॉन्ग, व्हाट हैपेंस ड्यूरिंग सीरीज कनेक्शन? सीरीज में सेम करंट फ्लो करता है, पैरेलल में सेम करंट फ्लो नहीं करता है. सो व्हेन द सेम चार्ज इज फ्लोइंग, देन द amount of chemical reaction that will take place will also be equivalent. Okay, why different weight deposition? Because यार electrochemical equivalent is can also be different. Electrochemical equivalent can also be different. The quantity is the same, quantity is not the same, charge is same, quantity is not the same. Okay, for copper I required 2 electron for depositing 1 mole, but for silver, okay, so if I take silver, Ag plus changes to Ag, how many moles of electron do I require to deposit 1 mole of Ag? How many moles do I require to deposit 1 mole of Ag? I require 1 mole of electrons. In copper, to deposit 1 mole of copper, I require 2 moles of electron. So the charge required changes, okay? Electrochemical equivalent changes. So that is why, okay? चलो, let's take up a question. एक क्वेश्चन लेते हैं, इसको सॉल्व करने की कोशिश करते हैं. In the electrolysis of aqueous CuSO4, a current of 2.5 ampere is allowed to flow for exactly 3 hours. How many grams of copper and liters of oxygen which is evolved? Okay? So, इसके लिए reactions याद रखना होता है. So reactions क्या होंगे? Cu2 plus will take up 2 electrons and form Cu. So look over here, how would I be solving the question? And it is very vital that you solve the question like this. So let me write it again. 2 electrons plus Cu2 plus changes to Cu, and water का oxidation reaction इस तरह से होगा. H2O will change to O2 plus 4H plus 4 electrons. Okay, 4 electrons. Clear? Now, how do I solve this question? Can I say that 2 Faraday is required for 63.5 grams deposition? Can I say 2 Faraday is required for 63.5 grams deposition? Can I say that? Please reply. 2 Faraday, because 2 moles of electron is required for deposition of 1 mole. 2 moles of electron is equal to 2 Faraday. So 2 Faraday is required for 63.5. Now, कितना Faraday ये होगा ये हम आइडेंटिफाई कर लेते हैं. 1 Faraday will deposit 63.5 upon 2 grams. And how much Faraday is this? So 2.5 amperes. This is current. And this is time, which is 3 hours. So 3 hours will be equal to 3 times 60 seconds. So 2.5 times 3 times 3600 coulombs of charge. 3 times 2.5 times 3 times 3600 coulombs of charge. Now this coulombs has to be converted into Faraday. This coulombs has to be converted into Faraday. तो मैं इसको 96500 से डिवाइड कर दूंगा, and I will be depositing, unitary method लगा रहे हैं. This is the number of Faradays. 1 Faraday was depositing this, so this Faraday will be depositing 63.5 upon 2 times 3 times 2.5 times 3600 upon 96500. Okay? Isn't it? The question will be solved like this. Okay, you will get a value. कितना value आ रहा है? Somebody said, Mohammed Zunaizur, 8.8 gram. Okay? Try and understand. It's very simple. How much Faraday is required for depositing, or how many moles of electron is required? 2 moles of electron is required for depositing 1 mole of copper. Okay? 2 moles of electrons is required for depositing 1 mole of copper. That is obvious from the equation. 2 moles of electrons will carry 2 Faraday of charge. So 2 Faraday is depositing 63.5. 1 Faraday will deposit 63.5 upon 2 grams. And itne Faradays, how did I calculate these many Faradays? Current times T upon 96500 gives me the number of Faradays. Gives me the number of Faradays. So these many Faradays will deposit this mass of substance. Okay? This mass of substance. Okay? Can you explain first line once again? यार first line और कितनी बार? 2 Faraday is depositing this many grams. इसको फिर से समझ लीजिए. 1 mole of electron carries 1 Faraday charge. So 2 moles of electrons will carry 2 Faraday charge, which is depositing 1 mole of copper, whose 1 mole of copper's atomic weight is 63.5 grams. Okay, and what for H2O? H2O के लिए कैसे solve करेंगे? So okay, I'm erasing this part. So H2O के लिए कैसे solve करेंगे? What is the number of electrons that you can see over here? Okay, what is the number of electrons that you can see over here? अरे शिखा, it is given 2.5 amperes. यार देखो यहाँ पे, it's given as 2.5 amperes. How many electrons are given over here? 4 electrons. So can I say 4 moles of electrons are responsible, are given out when 1 mole of O2 is liberated. 1 mole of O2 is liberated. 4 moles of electron is given out when 1 mole of O2 is liberated. Yes. Further हम क्या लिख सकते हैं? 4 moles of electron के ऊपर चार्ज कितना रहेगा? 4 Faraday of charge for 32 grams of oxygen. Okay, 32 grams of oxygen. 32 grams लिखने की जगह सिंस हमें लीटर्स में निकालना है, तो मैं ये लिख दे सकता हूँ डायरेक्टली कि 22.4 liters. Okay, I can directly write 22.4 liters because 1 mole of oxygen occupies 22.4 liters. Okay, so 4 Faraday charge if is given out, I will get 1 liter of oxygen. Cool. 4 Faraday of charge if is given out, I will get 1 liter of 22.4 liter of oxygen, which is obvious from here. 1 mole of oxygen will occupy 22.4 liter. I can directly write volume over here. अब बताइए, 1 Faraday will be 22.4 upon 4 liters. 1 Faraday will liberate how much? 22.4 upon 4 liters. And how many Faradays did we calculate over here? 2.5 times 3 times 3600 upon 96500 Faradays. These many Faradays will give 22.4 upon 4 times 2.5 times 3 upon 3600 upon 96500. Okay, how much are you getting? Did you understand? Is that understood? 4 Faraday charge is given out for liberating 1 mole of oxygen. 1 mole of oxygen is occupying 22.4 liters at STP. So 1 Faraday will liberate 22.4 by 4. So these many Faradays will liberate 22.4 multiplied with this new unitary method से solve कर दिया हमने. Answer कितना आ जा रहा है? What is the answer that you are getting? 1.5. चलो इसको 1.5 लिख देते हैं. So why I am asking you to use this 1.56 आ रहा है. चलो, why I am asking you to use this, because सारी जगह पे आपको बताया जाता है कि n factor यूज करना है. In all cases, in all books and all teachers tell you to use n factor, but I want you not to use n factor to solve these questions. Okay, कहीं भी हमने n factor लिया? Have I used n factor over here? I have not used n factor over here. Okay, I have not used n factor over here. So how to use n factor? अबे n factor use करने की जरूरत नहीं है. n factor बिना use करके आपका आंसर आ रहा है. ठीक है? So why do I need to use n factor? N factor is used to calculate electrochemical equivalent, but I do not need that. Okay, so please remember, the question can be solved in various ways. I can use n factor, I can choose not to use n factor. I have used a method where n factor is not required and we can get the result. ठीक है? चलो, let's take the next question. Okay, let's take the next question. A current of 0.550 ampere deposits 0.55 gram of a certain metal in 100 minutes. In 100 minutes. Calculate the atomic weight of the metal if the equivalent weight of the metal is 1/3 of the molecular, 1/3 of the atomic weight. इसको हम बोल देते हैं atomic weight. यार जब मोल कंसेप्ट डिस्कस करेंगे ना तब सिखा देंगे कि एन फैक्टर कैसे कैलकुलेट. एन फैक्टर बहुत सारी चीज़ों में अलग अलग तरीके से कैलकुलेट करते हैं. यूजुअली एन फैक्टर इज द नंबर ऑफ इलेक्ट्रॉन्स विच आर लॉस्ट और गेन्ड पर मोल ऑफ सब्सटेंस. ओके, बट वी डोंट नीड दिस राइट नो. व्हाई डू यू वांट टू ओवरली कॉम्प्लिकेट दिस? बिना यूज करके सॉल्व हो रहा है क्वेश्चन. सो क्वेश्चन देख लीजिए. अ करंट ऑफ 0.550 एम्पियर, तो आई की वैल्यू दी गई है 0.550 एम्पियर्स. I is given, time is given which is 100 minutes. So 100 minutes will be equal to 6000 seconds. I'll be 6000 seconds. Mass or weight is given as 0.55 grams. And यहाँ पे बता दिया कि equivalent weight is 1/3 of the atomic weight. So जब भी ये स्टेटमेंट आपको दिया जाए, whenever you are given equivalent weight को आप इलेक्ट्रोकेमिकल इक्विवेलेंट जो Z से आप रिप्रेजेंट कर रहे हो और E से रिप्रेजेंट कर रहे हो उससे रिलेट कर दो. ओके, सो इक्विवेलेंट वेट इज 1/3 ऑफ द एटॉमिक वेट. सो आवर E वैल्यू और Z वैल्यू इज नथिंग बट द एटॉमिक वेट विच इज लेट्स से x/3. This is what is given in the information. So how do we solve this question? I just put the equation in this form. W equals to ZIT upon 96500. W is given as 0.55. E value is given as x/3. I is given as 0.550 times 6000 upon 96500. Okay. The right answer you are get, what is the answer? 50 grams. चेक कर लो यार, 50 grams आना चाहिए या नहीं आना चाहिए. So this is 0.55, this is 0.55, so ये cancel हो जाएगा. So this will be equal to 2000, almost 96, no 96, 48.25 होना चाहिए. Answer, it should be C. Okay, my calculation says that it should be C. C आना चाहिए. Because this 0.55 will get cancelled out, and 3 और ये 2 हो गया, and 2 96.5 है. So 96 is equal to 96 divided by 2 will be equal to 48. तो 96.5 है तो 96.25 हो जाएगा. तो right answer will be 48.25. If you are getting 50 तो closest आपका 48.25 है, तो 48.25 मार दीजिए. ठीक है, आंसर इजीली आ गया. Problem 3 is your homework. Okay, problem 3 is your homework. और इस प्रॉब्लम को सॉल्व कीजिए एंड प्लीज डू रिमेंबर दैट वी विल डिस्कस दिस प्रॉब्लम एंड इन द नेक्स्ट सेशन वी विल हैव अ प्रॉब्लम सॉल्विंग सेशन ऑन Faraday's law. So we will take some difficult questions, some typical questions, some atypical questions, थोड़े एडवांस लेवल के, थोड़े मेंस लेवल के क्वेश्चंस हम लोग लेंगे एंड उनको सॉल्व करेंगे. सो वेंसडे का सेशन प्रॉब्लम सॉल्विंग सेशन रहेगा Faraday's law पे. प्लीज़ डू ज्वाइन अस ऑन दैट सेशन एंड प्लीज़ प्रैक्टिस करके आइए सो दैट आराम से आपसे सॉल्व हो जाए. ठीक है, सो दिस इज सौरभ गोस्वामी टेकिंग लीव एंड आई विश यू ऑल द वेरी बेस्ट. वेंसडे मुलाकात होगी एंड वेंसडे हम लोग डिस्कस करेंगे Faraday's law. प्रॉब्लम सेशन रहेगा. ओके, ठीक है, चलिए बाय बाय गाइज एंड हैव अ लवली टाइम.